7.4 properties of logarithm. So you're going to need to simplify. So for second period, you're going to simplify log base 5 of 25 squared. And you need to do it in red. For third period, in purple, simplify log base 6 of 36 cubed. For fifth period, in green, you're going to simplify log base 7 of 49 to the fourth. And for sixth period, in pink, you're going to simplify log base 9 of 81 to the fifth. And this is going to be due on Thursday at the beginning of class. So we're going to talk about properties of logarithms. Remember that logarithms are exponents. Therefore, we can derive the properties of logarithm from the properties of exponents. So you guys remember that when we had b to the m times b to the n, since the bases were the same, then you just added the exponents. Well, this applies to logarithms. So if we have log base b of m times n, this is going to equal to log base b of m plus log base b of n. So let's do an example. So if we have log base 3 of 10 times 100, this is going to be the same thing as log base 3 of 10 plus log base 3 of 100. So that's your product property. Now remember when we would divide exponents, for example, b to the m divided by b to the n, then we just subtracted the exponent. It was b to the m minus n. So from here we can derive the quotient property of logarithms. So if we have log base b of m divided by n, it's going to be the same thing as log base b of m minus log base b of n. So let's do an example. If I had log base 5 of 4/3, this is going to be the same thing as log base 5 of 4 minus log base 5 of 3. Both of these properties can be used in reverse. So let's do another example. Let's say that we had log base 4 of 2 plus log base 4 of 3. We can turn it into a single logarithm by writing it as log base 4 of 2 times 3, which is the same thing as log base 4 of 6. Now, what if we had log base 2 of 8 minus log base 2 of 4? Well, we can simplify and write it as log base 2 of 8 over 4, which is the same thing as log base 2 of 2. And remember from the previous section that when we have log base b of b is just equal to 1. So in this case, since we have log base 2 of 2, then our answer would be 1. So now let's talk about the power property of logarithms. The logarithm of a power is the product of the exponent and the logarithm of the base. So if we have log base b of a to the p, this is the same thing as p times log base b of a. So what are you doing? You're just bringing your exponent to the front. So let's do an example. What if I have log base 3 of 81 squared? Well, if I bring my exponent to the front, this is going to be the same thing as 2 log base 3 of 81. Now, if I want to evaluate for this, I can evaluate for log base 3 of 81. If I set it equal to x, then I can write it as an exponent. So then I'm going to have 3 to the x equals 81. Well, 3 to the x equals to 3 to the fourth, because 3 to the fourth will give you 81. Therefore, x equals 4. So then we can say that 2 log base 3 of 81 is the same thing as 2 times 4, which is just 8. And that's how you simplify. Let's do another example, but now I'm going to show you a different way to grasp the concept. What if you have log of 10 cubed? If I bring it to the front, then this is the same thing as 3 log of 10. Well, log 10 cubed is the same thing as log of 10 times 10 times 10. And if we use the product property, we can rewrite this as log of 10 plus log of 10 plus log of 10. As you can see, I have 3 logs of 10. So as you can see, you end up with the same answer. Now let's talk about the inverse property of logarithm and exponents. So if you have log base b of b to the x, it's just equal to x. If you have b to the log base b of